Hello everybody. Now I'm going to discuss about the Orgel diagrams. Mainly these Orgel diagrams is useful to find out the transitions possible in metal complexes. In metal complexes, particular electronic systems, in d-electronic systems, how the transition will take place from lower energy level to higher energy level, and how many possible transitions are there, and how many bands, what type of bands will taking place in the metal complexes we're going to discuss in this video. So generally, the Orgel diagrams concerned with the weak field complexes, where in weak field complexes, as we know, the inter-electron repulsions are more power than the ligand field strength. The magnitude of inter-electron repulsion is more, right? And in these type of complexes, the electron configuration will split into terms due to inter-electron repulsion. Again, the terms will split into states due to ligand field strength, that is LS coupling, right? And these diagrams mainly useful in interpretation of spin allowed transitions of tetrahedral as well as the high spin complexes of octahedral complexes. And for the comfort, Orgel has divided all the DN configurations into three groups, and he has constructed diagrams for each kind. The three groups are D1, D6, D4, D9 is the first set of configurations, D2, D7, D3, D5, D8. D3, D8 is the second set of configuration, and the third set is D5. So before we going to know the Orgel diagrams, 3 points to be noted. One is D and D5 plus N configurations will called as normal configurations, and these configurations will have same type of diagrams. And second note is D and D10 minus N configurations can be called as whole reverse configurations, and they can have inverted diagrams, that is reverse diagrams. Reverse type of splitting diagrams will have. And third point is, as we know from coordination chemistry crystal field theory, the octahedral and tetrahedral complexes. In octahedral and tetrahedral crystal fields, the splitting diagrams are inverted to each other, that is reversed to each other. Right? So, first we'll construct the Orgel diagram for first set D1, D6, D4 and D9. So, the ground state term for all these four electron configuration is ND. So, if you see the D1, so one electron is occupied in the subshell of d orbital. So we have given the d orbital values +2, +1, 0, -1, -2, right? So from this, the electron is occupied here. So the L value is +2. So therefore, the term symbol is D. And if we calculate the spin multiplicity, that is 2s plus 1. 2 into where s is n by 2, that is a number of unpaired electrons by 2, right? So 2 into unpaired electron is 1 here. So 1 by 2 plus 1. So it is 2. So the ground state term for D1 is 2D, right? So according to whole formalism, D D10 minus N configurations are whole reverse configurations, and they can have same number of microstates and same type of term symbols, right? So for D1, the ground state term is 2D. Again, D1's whole reverse configuration, D10 minus N is 9, right? So D1, D9 will have same type of term, that is 2D. And if we work out for D4, for D4, 4 electrons are there. 4 electrons will occupy like this, and L values +2, +1, that is +3, +0, -1. Therefore, L equals to 2. So the obtaining term is D. And spin multiplicity 2s plus 1 will be given as 2 into number of unpaired electrons are 4 here, right? So 4 by 2 plus 1. So therefore, the n value is 5. That is spin multiplicity is 5. So the term symbol is 5D. So D4's whole reverse configuration is D6, right? So D4, D6 will have same type of term symbols, 5D. Okay, so if we construct the Orgel diagram for D1 configuration. So for D1 configuration, as we know, the ground state term is D and N is 2, right? So for D1, N is 2. So the splitting diagram will take place as lower energy level is T2G and the higher energy level is EG. So the possible transition is N is 2, right? So spin multiplicity is 2. Doublet T2G to doublet EG, right? So as we know, now discussed, right? So DN, D5 plus N configurations will have same diagrams. So here Dn, D5 plus N, that is D1, D6 will have same diagrams. D4, D9 will have same diagrams, right? So D1, D6 will have the same diagrams because Dn, D5 plus N will have calling as normal configurations. So they will have the same type of splitting, right? So it is for D1, D6 octahedral splitting. So if we want to split in, if we want to take the diagram, splitting diagram in tetrahedral field, what will happen? Completely reverse splitting to octahedral splitting, right? So the lower energy level is Eg and the higher energy level will be considered as T2G. Okay. So next, if we consider the D9 electronic system. So D1's whole reverse configuration is D9 and D1 will have, the D9 will have reverse diagram for the from the D1 configuration, right? So whole reverse. So the lower energy level is Eg and the higher energy level is T2G. It is for D1, D9 octahedral. So for D9, N equals to 2, right? So the possible transition is 2 Eg to 2 T2G. And for D4, it is N equals to 5. So for D4 also, so D4, D9 or D9, D5 plus N, like normal configurations, right? So they will have same type of diagram. So D4, this constructed diagram is applicable for D9, D4 octahedral diagram, right? So if we want to write the transition for D4 octahedral system, what will happen? 5 Eg to 5 T2G. So N value is 5 here. So 5 Eg to 5 T2G, the transition is taking place. So if we construct the diagram, the common diagram for these 4 electronic systems, it will be like this. So this is the energy versus crystal field strength. Okay. So as we constructed for D1, D1 T2G, EG. So D1 octahedral, same applicable for D6. So it is D1 D6 octahedral splitting, T2G to EG. So this reverse splitting is D1 D6 tetrahedral. So EG is the lower energy level and T2G will be the higher energy level. D1 D6 octahedral, same reverse splitting will be D1 D6 tetrahedral. So T2G is lower energy level, EG is higher energy level. Here EG is lower energy level, T2G will be the higher energy level. So if we come for D9, D4. So D1's whole reverse configuration is D9. D6 whole reverse configuration is D4, right? So D1, D9 will have reverse diagram. If it is D1 for octahedral complexes, so reverse diagram D9 of tetrahedral complex, right? So that it is D4, D9 tetrahedral splitting diagram. And then the reverse diagram D4, D9 octahedral diagram, right? So the possible transitions we can write from this diagram for 4 electronic systems of octahedral complexes and as well as tetrahedral complexes. Here, 3 things to be noted, that is Dn, D5 plus N configurations, normal configurations will have same diagram. D and D10 minus N, whole reverse inverted diagrams. Octahedral and tetrahedral inverted diagrams. So first, if we know the D1 configurations splitting, we'll write all the diagram according to D1's diagram. D1's octahedral is same for D6 octahedral. D1's whole reverse D9 tetrahedral, and D9 normal configuration is D6. D4 D9 tetrahedral complex is applicable as D1 D6 octahedral configurations. So if you see the second set of configurations, that is D2, D7, D3, D8. So the ground state term for this configuration is NF and NP. So if we see the D2, 2 electrons are there occupied in plus 2 plus 1. So L is 3. Therefore the term will be F. 2s plus 1 is 2 into number of unpaired electrons are 2. 2 by 2 plus 1. So spin multiplicity value is 3. So 3F. So D2, D8 are the whole reverse configurations. So they can have same type of terms, 3F, 3P. And for D3, 3 electrons are there, and L is 3, obtaining term is F. 2s plus 1 will be different. 2 into 3 unpaired electrons are there, right? 3 by 2 plus 1. So a spin multiplicity is 4. So 4F is the ground state term for D3, D7. Okay. So D2, D7 normal configuration, D and D5 plus N, right? So D2, D7 will have same diagram. D3, D8 normal configurations will have the same diagram. So if we construct for any one of the electron configuration, we'll construct for 4 configurations simultaneously. So if we go to construct the D2 configuration of octahedral complexes, the octahedral complexes of D2 electronic system. Okay. So the ground state term is 3F and the next term is 3P. So 3F, the F term will split into 3 energy levels. T1G, T2G, A2G. Okay. Lower energy level is T1G, T2G, and the higher energy level is T2GF. And 3P term will splits into only one energy level because it is triplet degenerate, right? So T1G from P term. So it will splits, the splitting diagram will be lies like this. So here 3 transitions are taking place. One is triplet T1GF to triplet T2GF, and triplet T1GF to triplet A2GF, and triplet T1GF to triplet T1GP. Okay. So if you see for D3 octahedral, so D2 octahedral will applicable same for D7 because Dn D5 plus N, right? So D2 D7 will have same type of diagrams. So D2 D7 octahedral diagram is same for D2 D7, this diagram, right? So D2's whole reverse configuration is D8, right? So D2's whole reverse configuration is D8 and D7's whole reverse configuration is D3. So if it is for D2 octahedral, the reverse diagram will be applicable for D8 octahedral, isn't it? It is same for Dn D5 plus N, and it is reverse for Dn D10 minus N. So if it is D2 octahedral diagram, the reverse diagram of this will be D8 octahedral configuration, right? So in D8 octahedral configuration, what will happen is the energy levels, the lower energy level is A2GF and the next T2GF, and the higher energy level will be takes place as 4T1GF, and this energy level from 4P. Here one thing to be noted that when the energy levels of different terms with the same symmetry T1G, T1G approached together, what will happen? The non-crossing has taken place. There is no crossing between the energy levels. Whereas here, the crossing between the energy level will be takes place. But here, non-crossing has taken place. So, due to that, the energy of lower energy level will be lowered. The energy of higher energy level will be higher. This is said to be non-crossing rule. Okay. So, here also 3 transitions. One is 4A2GF to 4T2GF. Again 4A2GF to 4T1GF. 4A2GF to 4T1GP. 3 transitions will be takes place. If we combine these 2 diagrams, we'll get the only one diagram which is mainly explains the Orgel diagram for more of 4 electronic systems. So what we have discussed, D2 octahedral we already discussed, right? So T1G is the lower energy level, T2G is the higher energy level, and A2G will be the higher energy level, and this T1G from P term, right? So 3 transitions will occur. So if it is D2, D7 octahedral, its whole reverse configurations D8, D3 tetrahedral configuration, tetrahedral splitting, right? So if it is D2, D7 octahedral splitting, so its reverse splitting diagram will be D2, D7 tetrahedral. Clear? If it is D3, D8 tetrahedral splitting, so its reverse splitting is D3, D8 octahedral splitting. So here one thing to be noted that when we writing the transitions in octahedral, we can write T1G to T2G, G subscript. We can add the G subscript. But when we writing the tetrahedral transitions, we should not add the G subscript because tetrahedral is not having the centrosymmetry, center of inversion, right? So that it is ungeared. So when we writing the transitions like T1GF to T1GP, so we should not add the G subscript. Okay. In coming videos, I will discuss for several octahedral complexes and several tetrahedral complexes, and will write the electron transitions. Okay. So this is about D2, D7, D2, D7, D3, D8 electron configurations Orgel diagram. So the last set is D5. D5 transition, D5 Orgel diagram is there is no allowed transitions, spin forbidden transition. All these transitions are spin forbidden transitions because if you see the ground state term is 6 years and the next energy levels are quartet G, quartet P. Spin multiplicity is 6 here, spin multiplicity is 4 here. So there is no allowed transitions. All are spin forbidden transitions. Okay, 6 state S will remains as a single energy level as 6 state A1G. Quartet G will splits into different 4 energy levels 4A1G, 4EG, 4T2G, 4T1G. And where from P term the T1G energy level has taken a sigmoidal curve. When the D term, the two energy levels EG and T2G, right? So when the energy levels with the same symmetry from different terms T1G and T2G, when they approach together, the distortion of symmetry is taking place. They are taking the sigmoidal curve. Okay, this point to be noted. And then 4F term will split into 3 different energy levels. The 4 A2G is the lower energy level, T2G is the next, and T1G is the higher energy level. So this is about Orgel diagrams. In coming videos, we'll discuss the Orgel diagrams which are applicable for octahedral and the tetrahedral complexes.